G'day guys, we've been given an applications of differentiation question to do today where the question says that the right triangle shown, this one here, has sides AB and BC which are able to vary in length while AC is fixed at a length of 10 centimeters and angle ABC is always a right angle. Initially, AB is of length 4 centimeters and increases at a constant rate of 0.1 centimeters per second. Find the rate of change in length of BC 20 seconds after the side AB increasing commenced. Okay, so what we have to do first is we're going to have to find a relationship which links x, y, and this 10 centimeters. So we're going to use Pythagoras to start with, and our starting relationship is going to be x squared plus y squared is equal to 10 squared, or 100. Now we can rearrange that so we can have y in terms of x, and that's going to be y is equal to square root of 100 subtract x squared. So not too difficult to start with. Now the tricky parts of this question come where we have to try and find how to work out the derivative. Now it says here, find the rate of change in the length BC. Well, that's BC here. And so when we have rate of change, we're talking about time now. So we're being asked to find dy dt. That is the question when t equals 20 seconds. Cool. So to start with, what we're going to have to do is we're going to have to work out, well, the method of working out dy dt when we only have x and y here. And we're going to employ the chain rule. Hopefully you guys are aware of the chain rule. So what that basically says is we're going to find dy dt. That is going to equal dy dx, which we can find quite easily, times dx dt. Now, dx dt is given to us 0.1 centimeters per second. So what we can do in a different color, we will just write that down for our own benefit. We have dx dt is equal to 1/10. Cool. So, first of all, we're going to have to work out what this thing here is. So let's go about doing that. Dy dx, so this one here, dy dx, can be written as y is equal to 100 minus x squared to the power of a half. Now I'm assuming you guys are fairly proficient at differentiation, but I'm going to go through it with you anyway. So we have dy dx will be equal to, we move the half down the front, 1/2 100 minus x squared to the negative 1/2 times by the derivative of the inside, which is negative 2x. Now the negative 1/2 will take that 100 minus x squared into the denominator. This 2 and that 2 there will cancel out, and we're going to be left with negative x divided by the square root of 100 take x squared. Cool. So that's our derivative dy with respect to dx. Now, there is a reason why they have given us this 20 seconds after, because we have to compute dy dx. We've got to evaluate it when t is 20. So we're going to have to work out what x is when t is 20. So x at 20 is going to be equal to, it's initially at 4 centimeters, 4 plus 20 times the rate, which is 0.1. So that's going to be 4 plus 2, which is 6. So we can evaluate dy dx when x is equal to 6. So dy dx evaluated when x equals 6 will be equal to negative 6 on 100 minus 6 squared is 36. The square root 100 minus 36 is 64. The square root of 64 is 8. Cool. Now, so we can take this up here and say that, well, therefore dy dt is going to be equal to dy dx evaluated when t is equal to 20, which is negative 6 over 8 or negative 3 over 4, multiplied by dx dt, or 1 on 10. So that's going to be negative 3 on 40, or 0.075 centimeters per second. Full stop. Cool. So this is, a basic applications of differentiation question where the only sort of nuance to it, so to speak, is the fact that we have to employ the chain rule to basically integrate the dt into this relationship that we find at the start, which is x squared plus y squared equals 100, which you can see t is nowhere to be found. So basically, if we can understand that to introduce a new variable t, we need to employ the chain rule. That's got to be kind of be a if this, then this sort of thought process in your head when this exam is coming around. So, guys, just keep practicing it. It's not too complicated. I'll introduce a few more complicated applications of differentiation questions, but at a high school level, this is the kind of stuff you can expect in an exam. So just keep practicing this, and I'm sure you won't have any problem when the exam hits. So, yeah, keep enjoying your maths. If you have any problems, ask me them in the comments section below. I have absolutely no problem in trying to do, viewer questions. But until next time, guys, enjoy your maths.